Hello, my name is Shekinah Edwards and I'll be doing my Teach 1 presentation on how to import data into SMSS and PostgreSQL. We will start by downloading the dataset from the Canvas page for the Module 2 assignment on importing data. Next, we will extract the files. For the purposes of this tutorial, I moved the zip file from my Downloads folder to my desktop because it was less cluttered. Windows users can right-click the zip file and select Extract All. This will extract the contents of the file into a folder where the file is located, in this case, my desktop. Inside, you will see 4 other zip files. These are 4 parts of the whole dataset. Once again, we will use the Extract All to get the contents of each file. To declutter, I put the original compressed files in a new folder named temp. Now we will import this data into SMSS. To open SMSS, click on the applications icon. This should have appeared after its installation process. I have pinned this icon to my taskbar because it's more convenient for me. I'm showing you how long it takes real time on my computer for the application to boot up, so you know it may take some time depending on your computer. Once the application is launched, you can connect to the server you created also during the installation process. Now we will create a new database. To do so, you'll need to right-click the database folder in the Object Explorer and click on New Database. You will see a window that prompts you to name the new database. In my case, I named it after our department and class number, HI 671. You may name your database whatever you may like, but be sure that you do not use any spaces. If it hasn't shown up in your Object Explorer already, you can press the circular arrow button to refresh your database or right-click it and press Select. It should appear in your Databases folder. Next, we will import the files. Right-click the new database, hover over Tasks, then click Import Flat File. A new window will open and you will click the Browse button and navigate to where the first CSV file of the dataset is located. Once again, my file is on my desktop, but yours may be in your Downloads folder. Soon you'll need to select the data type for each column. We will set it to nvarchar 50, which is an array of characters with the maximum amount of characters being 50. We will allow null values as well because they are important. For example, you can tell a patient is living when they have a null value for age at death. After you're finished doing so, press refresh. After completing the previous step, you should see this confirmation message in your console. It's showing that the import data process has been successful. You're going to repeat these steps to import the tables for the other 3 files we have downloaded. After doing so, you should see that the following tables are in your database. We will be executing queries soon, but before we do so, we need to make sure we are executing them within the right database. We can have multiple databases in a server, but to use a specific one, we do the following. We click New Query and we type use and then the database name. In this case, mine is HI 671. After that, you execute the query. After completing that step, you should get the following message in your console saying that it has been completed successfully, but you will also see in the bottom right hand corner that the name of your database is present. Usually when you open up SMSS, you're automatically in the master database. But by seeing that the name of your database is in the bottom right-hand corner, you know you're in the right place. Next, we will create and initialize a temporary table. We are using a temporary table as a placeholder to merge all of our tables. We do so with the following query. Select star name of temporary table from name of table source. This query will copy the data as well as the structure of our table source and use it to create the new temporary table. It is important to note that the temporary tables are preceded with a #. In this image, you can see that as you type, the application may give you suggestions on which objects you would like to select. Using your up and down arrows on your keyboard, you can iterate through this list. To select and thus autofill, you press Tab. Now we will add the rest of the data to the table. We do that with the following query. Insert into destination table, in this case the temporary table, select star from source table. Similarly to the last query, it will select all the data from our source table and paste it into our destination table. However, this assumes that the destination table already exists, so take note of the different syntax. After you write this query the first time, I recommend copying and pasting it the other 2 times to work efficiently. Just be sure that you change the name of each source file so you don't duplicate the queries. In the video, I want to show you some keyboard shortcuts to help you work faster. If you do Shift plus Home, you can select a whole line. And if you do Alt X, you can execute the query. We have now merged all the data into the temporary table. We can look at the first few rows of this table by running the following query. Select top 10 star from table name. You can change the number to any value you like, and it will show the appropriate numbers of rows accordingly. We can see here that our table has the following columns: ID, ICD-9, age at diagnosis, age at first DM, age at death. Okay, our data is merged together, but there is still an issue. All the data types are of varchar. This data type does not best represent all of our variables. So as we move the data to the final table, we will change the data types. To do so, you will use the function try_cast. This function will try to change the data type to what we indicate, but if it can't, it will just return a null value. As we've previously done, we will select which columns from our source table we want in our destination table. We will do this by using the select keyword, listing the columns we want, using the into keyword to indicate where we want to copy this data to, and then the from keyword to indicate where this data is coming from. Like step 7, this will create and initialize the destination table because it is copying the data and structure from the source table. In this case, the source table is the temporary table, and the destination table is called dbo.final. When we are listing columns, we want to use the try_cast function if applicable. This function requires the column name and data type we want to convert to, preceded by the as keyword. Outside this function, we can name the column by reusing the as keyword and typing in its new name. In this case, it's the same as the original column names. The only column we did not convert was the ICD-9 column because these codes are alphanumeric. Once you run this query and refresh your database, you should see this table populated in your Explorer. When you look at its columns, it will have the same columns, but with its converted data types. Now we will try importing the same data into PostgreSQL. To open PostgreSQL, click on the application's icon. This should have appeared after its installation process. I've pinned mine to my taskbar because it's more convenient for me, and I'm showing you how long it takes real time on my computer for the application to boot up, so you know it may take some time depending on your computer. Once the application is launched, you need to type in the password you created also during the installation process. Unlike SMSS, Postgres requires that you first create a table object, then import the data into it. SMSS, as we've seen, combines these steps. We will click on our database, navigate to schemas, then tables. We will right-click on it and select the query tool. We will run the following query: create table, table name, then in parentheses, list the column names and their respective data types. They will all be of the type varchar 50. Right-click on the Databases folder and refresh to see the new table in the Object Explorer. Then you're going to repeat for the next 3 tables. Next, we're going to import data into each table. To do that, we're going to right-click on each table and select Import Data. Then you'll click on the folder icon and navigate to where that respective file is, whether that be your desktop, downloads folder, or otherwise. In the query window, we will create a new table that we will put all of our merged data into eventually. Using the same syntax as before, I named this table Final and changed the data types to the following: ID as integer, ICD-9 remained the same, and then every column that represents age was changed to a float value. So for the 14th step, we're going to initialize the final table and format the columns data types. However, we do not have the try-cast function in Postgres, so we will have to circumnavigate the issue of changing the data types of certain columns. This will require multiple components. Component 1 is a regular expression. This is a function that uses an expression to look through the text for a pattern. If there is a match, it will be replaced with whatever we tell it to. There is an optional parameter called flags, and we will use the G flag, which means global replacement, to ensure that this iterates through all the rows in the column. Component 2 is a null if function. This checks if both of the arguments are equal. If so, it returns a null value. Component 3 is the cast function. Its shorthand is 2 colons. On the left side of the colons, you put the value you want to convert. On the right side has the data type you want to convert to. An overview of the workflow will be the following. For each row in the column indicated, it will check if a pattern is present. If so, it will replace it with an empty string. Otherwise, it will be left alone. Then there will be a check to see if this output is equal to an empty string. If so, it will return null. Otherwise, the output will be left alone. The output for this will be casted into a new data type. It is okay to cast null values here because it won't throw an error. As we can see in the code, the first column that we are dealing with is the ID column. The regular expression checks for \d, which represents any non-digit character. So if there's any non-digit character here, we're going to replace it with the empty string. For the age at dx in the following columns that represent age, the regular expression are looking for anything that's not a number or a period. Otherwise, it's going to return an empty string. Then, for all the lines that have null if, it's going to check if there's an empty string here or something with content, essentially. And if so, it's going to cast it to the following data type. The only column that didn't get any treatment was the ICD-9 because we want it to be a varchar data type. We would run the previous query 3 more times, each time replacing the from value with the name of the next table that we've imported earlier. And then we can view our final table by right-clicking it in the Explorer menu and clicking on View/Edit Table. And we can look at the first 100 rows, as you can see here. Thank you for your time. That was my presentation on importing data to SMSS and PostgreSQL. I hope that it was helpful, and please leave any feedback that you think would help me in the future. Bye.